Welcome to Developer Service YouTube channel. On today's episode, we're going to be talking about how we can automate the boring stuff by deleting Python's virtual environments that are occupying disk space on your computer. As Python developers, we're constantly spinning up new projects, experimenting with libraries, or testing new ideas in isolated environments. Over time, it leads to dozens, maybe even sometimes hundreds, of virtual environments scattered across our system. While they do serve an essential purpose for dependency management, they also come at an invisible cost. They can clutter and waste disk space. I created the Virtual Environment Analyzer, which is a Python script that analyzes directories to find virtual environment folders and displays information about their size and count. Now also with a cleanup functionality that deletes large virtual environment folders and automatically clean up unused space. Some of the features include comprehensive detection, which can identify various types of virtual environment, size analysis, so it calculates and displays the total size for each folder. It outputs in Human-readable format. It has a flexible search, so it can support custom directory paths and search depth limits also. Graceful errors handling. A verbose mode to keep track of detailed information. Recently I added the cleanup mode and also unused virtual environment detection. I will not go through to all the code in detail. You can find the link in the description for the GitHub repository. I will go through the main functions and components of the code. The first we start by the find environmental folder function, which will all the virtual environment. This is obviously the root and the max depth, meaning the number of items to go through, and returns a list. We start by defining a list of the environmental folders, an empty list. Then we define an inner function that does the recursive search, which again receives the path and the current depth. If the current depth has already been achieved, then we return. If not, for each item that is in the path, we check if it is a directory, and if it is a directory, we check if it's an environmental folder, which the help of helper function. If that is the case, we append it to the list of folders. If not, we continue to search in other subdirectories by calling again the search recursive function. And if there is any error, we skip the directory because it most likely means we cannot access that directory. And of course, we do the search recursive with the root path, and that kicks off the recursive search, and then we return the folders. So like I mentioned before, the previous function uses is env-folder function, which checks if a directory is an environmental folder or not. So we do that by a specific set of characteristics. We do that based on name heuristics and also a structure-based indicator. So first we start by defining the common environmental folder names, venv, .venv, and so forth. Then we check if the folder matches with any of those names. If that's the case, then we immediately return true. If that is not the case, then we check for the structure-based indicators like the presence of scripts, the bin folder, activate.path. Again, we do the for in each of these indicators, and if the path corresponds to that indicator, then we also return true. If none of these two cases are true, then we return false, meaning it's not an environmental folder. Get directory size, the total size of a directory in bytes. So we start by initiating the total size with 0. We iterate through the list of the directories inside that folder that is passed the input of the function with our swap. We go through all the file names, or we go through all the files in that directory, and if we check if it is a file, and if it is a file, we just add the file size to the total. And if we cannot access the file, then we just skip the files we cannot access. Same thing if we find the directory that we can access, we just skip that directory and we return the total size. Another helper function to determine the virtual environment access time, so that gets the most recent access time for a virtual environment. We start by initializing that with 0. Then we check if it is environmental for the list access, we get the maximum date of all the directories inside, and we check the different paths. For each of the different paths, we check if the last access is greater than the initial value, and if that is the case, we assign that to the latest access value. And of course, again, we keep any files or folders that we can access. We return the last access date. And the main function that displays the whole results is the display results. So it receives an analysis, the root path, if it was verbose or not, if it's auto delete flag, a clean unused flag, or the days threshold, the auto delete. We print the statistics there. If it is the threshold, We return the results if no environmental environments are found. If it is verbose, we print out a detailed breakdown. If it's not verbose, then we just show the top 5 largest virtual environmental folders. We offer the virtual environment cleanup that shows how many disk space will be the deletion of the virtual environments that are unused. We check the reply of deleting those virtual environments or not. We do double confirmation. So if the first response is yes, we put in another confirmation, and if that is also corresponding to delete, then we delete the virtual environmental folder that we shown before. We offer the auto deletion option for the top 5 largest, and the previous one was for the unused ones. Again, we show that that value of how many disk space will be recovered in case we deleted them. And again, double confirmation to delete or not. And if that is the case, we delete the environmental folder, the top 5 folders in this case. And of course, the main function, it processes all the arguments, adds them to the document parser, validates if everything is correctly, and it calls the find environmental folders, the analyze environmental folders to analyze the results, and display results, and it processes the whole sequence as a whole. Let's see the example of the code we're running. Let me run the code. In this case, I run the code again to my environmental folder of the directory of the script itself, but you can see the analysis. So this was the folder that I passed. We found the folder. In this case, it's only 12 megabytes because we barely have any dependencies. Top 5 is just this one, showing that the last access date, which is just now working on the script. And since I didn't pass it, it will not delete the environmental folder. And if I do the auto delete, then you see now that it performed the analysis and it has the clean-all option that will free up the 12 megabytes for that original environment. And it's asking if I want to delete the folders. I'm just going to confirm. And it's asking for double confirmation. I will also confirm. It has deleted that virtual environment, the one that the script is now into. So if I run the analysis again, you see that it has found it has not found any virtual environment. If you found the script useful, also consider donating to support not just the developer service blog, but also the developer service YouTube channel. Feel free to any feedback is welcome. Like this video if you like this content. Subscribe for more content. Python, Django, and happy coding.